We are resuming lesson 2, characteristics of quadratic functions. In the first lesson, we were given a graph of a quadratic function, and we were asked to find these characteristics of the quadratic function: the shape of it, the leading coefficient, end behavior, y-intercept, x-intercept, vertex, minimum value, maximum value, domain, and range. You're given the graph of the quadratic function. And from yesterday, or the previous lesson, we discovered the shape is a parabola. So the graph is changing direction only once. And it's going in the same direction in the opposite direction, in the same direction as it appeared. We said it's either could be going down, in this case here, or it's going up. If it's going down, we said the shape is downwards. If it's going up, we said the shape is upwards. So in this case here, we have this parabola or quadratic is going up. If it's going up, the sign of a leading coefficient is positive. The end behavior refers to the quadrants. It's going from quadrant 2 to quadrant 1. And you always go, you record your end behavior based from looking at your x coordinates and your y coordinates. And as you move from left to right, or from negative to positive on the x-axis, what is happening to the y values? In this case, the y value is increasing, so we said it's coming from quadrant 2 to quadrant 1 as the x value increases. The x-intercepts, we discovered the x-intercepts here using our graphing calculator. So you'll need a graphing calculator or Desmos. So you'll need graphing calculator, or you'll need also Desmos. Sorry, you need a graphing calculator here, and this is Desmos. Okay, just don't want to mix the two up. They're different. There again, graphing calculator and Desmos. The minimum value is the y coordinate of the vertex. And we said the vertex is the point where the graph changes direction. If it's going up, it's a minimum. The vertex is a minimum point of the graph. If it's going down, we said that it's the maximum point of the graph. So in this case, the minimum value is, the vertex is -2, -4. So the y value of the vertex is the minimum value. There's no maximum because the graph goes to infinity. The domain, there's no restriction. This graph goes to -infinity and to positive infinity. So we said x is set of real numbers. There's a restricted range. The graph doesn't go below y -4. So we say that the graph is from -4, and we put a square bracket here, to infinity. So that's just when we're given a graph. Today's lesson, we are not going to be given a graph, but we're going to give an equation. And from the equation, you will have to derive these characteristics. So instead of given a graph, you're given an equation. So that's from yesterday's lesson now. And from the equations, you will be asked to describe the shape, the vertex, leading coefficient, end behavior, y-intercept, x-intercept, and the range. As I said before, you'll need your graphing technology, in this case Desmos, and the graphing calculator. Also, I would recommend that you have handy with you the sheet here, for instruction using the graphing calculator, and also the one in Desmos. I'm going to add one more formula to this Desmos here, and we'll talk about that when we get to the quadratic function. Oops. Okay. So these are the things you need. Along with it, you'll need your booklet, which is so you'll need your quadratic function unit 4 booklet. Okay, let's get right to it. So we're going to resume from yesterday, and now today here using a graphing calculator to determine the characteristics of quadratic function. So you're not given the graph. Now, before I go to there, now we know how to use our graphing calculator to derive an equation of a straight line or a linear regression. But we're not dealing with linear regression. Now we're dealing with quadratics. Okay. So how do we use our calculator to graph a quadratic? Okay. So that's on page 6. So we'll start today, and then I'll show you how to use Desmos to do to construct to derive your graph of a quadratic function. But let's look at the graphing calculator. So I'll zoom out here. So demonstrate this example for you, so you're quite familiar. Okay. So as before, we'll reset our calculator. Plus sign there. Go to number 7, params, and number 2, reset. So that will clear all record we have in your graphing calculator. Now, so we want to graph a quadratic. So we have y is equal to x squared plus 3x minus 1. So first thing you want to do is to enter step 1, your y equal button, and enter the equation and press graph. So we'll enter our equation, which is x squared plus 3x subtract 1, and then press graph. And there is your quadratic function. It should look exactly as you see here. So this graph opens up. Now, you want to find the minimum value. In other words, the lowest point here. In the questions we did, we were given the minimum value based on the graph. But today, we're not given that minimum value. We need to find it using a graphing calculator. So this is what you will do to find, and you follow the instructions here. So move up. So you press your second button and trace to access the calc menu. So second, trace. Once you get to this point, you want to find, now this graph is going up. So in this case, you'll find a minimum value. Okay. You don't want to go maximum because back to your graph. This graph is going up. So if the graph is going up, you will find the minimum value. Now, if the graph is going down, as we'll see in another example, then you'll find the maximum value. So second trace, we're going to number 3, minimum. And when you get there, you'll see a cursor flashing. Now, it may be on the right or it may be to the left. To move this cursor that's flashing there, we move the left to the left, we move left or to the right using these left or right arrow keys. Now, it says here left bound. What the calculator is saying, it wants you to go to the left of the vertex or the minimum point. Move it to the left side. So you move it to the left side. It doesn't have to go all the way up, just as long as it passes the minimum point onto the left. A message like this indicates that you should move the cursor to the left side of the vertex of the parabola. Once you've moved the cursor anywhere to the left of the vertex, you can press enter. So same as here, you press enter. It says right bound. Then you move it to the right side of the vertex. Once you're on the right side of the vertex, press enter again. And now you'll see the word guess. So what you do now, you can move the cursor closer to the vertex and press enter. And that's your minimum point. So the vertex here is negative 1.5, negative 3.25. And that should be the same as you see in your, on the page. So you'll want to practice this a few times. Remember, step 1, you clear your calculator, and then you enter the graph into the equation into the y1 line. And you follow the steps here. So there's your minimum value. Now be clear what this is going. Let's repeat again. Second trace, minimum. It says left bound. Make sure you go to the left side of it. Press enter, go to the right side of it. Press enter, press enter. And there's your minimum value. So let's go on to the first. These are, we have 1, 2, 3, 4, 5, 6 here. And then you have your assignment. So I'll go here, and I'll clear my screen. So the first equation is y is equal to 0.5x squared minus 2x plus 7. So I enter this into my y equal button, which is 0.5x squared. Or you could put 0.5x squared minus 2x plus 7. So if you want to know if this graph is going up, the end behavior, intercepts, minimum value, and domain. And also we want to find the range we want to set. So this graph, and notice what happens. This graph is way above the x-axis. So there's no x-intercept to begin with. What direction is going up. So we can write that up. The direction is upwards. So it's going up. That's what they tell us here. The parabola, so we can see parabola. is opening. Now here the sign of leading coefficient, we say it's positive. So we positive here. The end behavior now has to do with what quadrant? Now this is quadrant 1, this is quadrant 2. I'll do a sketch. I'll put a sketch across here so that indicates you. Now this graph is going. Oops. So this graph is going upwards. Now, coming down here a little bit here. Should be symmetrical. The end behavior is from quadrant 2 to quadrant 1. So we write quadrant 2. The x-intercept, if you go back to our graph here, there's none. Okay, so we say there's none. Minimum value, now we need to find a vertex. So we should find a vertex first. But before we find a vertex, let's find a y-intercept. The y-intercept is where it crosses the y-axis. So remember, to find your y-intercept, here's the instruction. Back to your instruction sheet. So we said second trace value, that x be 0, and y is 7. And we could have determined from looking at the equation. So we said the y-intercept is 7. Our coordinate here is 0, 7. Next, we want to find our vertex. When we know our vertex, we find our minimum value. So because there's no maximum value here, right? So we can put that down here. So none. Now, because this graph is going to the left forever and to the right forever, we say the domain is x is all the real numbers. Or if you like to write interval notation, the range we have to determine that from our vertex. So minimum value, we need to find that. So first of all, let's find our vertex. And to find our vertex, this is our instruction here. And we just did it on the previous page, right? So it's also here. So you can refer to page A6. So first of all, we go second trace, and then we go down to minimum. Now, left bound is already on the left side, so we can move it slightly like that. So that's left bound, so we already on the left side, so we don't have to move it. Press enter. It's a right bound, move to the right of the vertex. Press enter. Press enter 2 more times, and this is your minimum. So your vertex is 2, 5. X is 2, y is 5. The y value is your minimum value. I guess we can write here your vertex is, oops, that's 0, 5. So we have here, the vertex is 2, 5. The range now, range refers to the y value where this graph is valid. And the range is from the minimum value to infinity. So we say that the range is from 5 and close bracket to infinity. Let's look at the next question. Next one, this will look like a parabola. Let's see. Well, don't let that deceive you, because we have to enter this into our calculator. Oh, by the way, maybe I should show you by now how to use Desmos. Okay, this is for your Desmos users. I'm sure there are lots of you using Desmos. Now, I'll show you how to use Desmos to find the vertex, the y-intercept, etc. So let's go back to our equation. Now, we already used our graphing calculator, so now let's go to Desmos. Okay, go back to our instruction sheet. So on our instruction sheet, I already have Desmos open. So we don't have to do any clicking here. We just want to input the equation. Right? So all we're going to do, you are going to put the equation exactly as it is here. That's all there is to it. Okay, in terms of putting in the equation. So you press your cell button here, and you press y equals 0.5 x squared. Now this is your square root of your x, and this is your power 2 button. Then we go to minus 2x 2x plus 7. Okay, so there is your graph, but it seems to be way out of your view or your window. So what you want to do is to touch this, and now there you can see your graph. Now you can pinch these and zoom in and zoom out. Now to find your vertex, well, now we can look at directions going up, quadrant 2, oops, back here. So we go from quadrant 2 to quadrant 1. There's no x-intercept. But now we need to find our y-intercept. So the y-intercept, you pinched it. And where you see the y-intercept, you just tap on it twice, and there it is. X is 0, y is 7. So that's your y-intercept, exactly as we have here. Your vertex, the lowest point, you tap on it, and it's 6.8. Now, did I enter my equation correctly? 0.5. Oh, look at that. I did not enter my equation correctly. So I need to, there you go. Okay, now that looks right. Let's go that again. We'll still have the same y-intercept because my 7 was entered. Now I tap that, 0, 7, and it's 2, 5. Exactly as what we have in a graphing calculator. So with Desmos, it's much simpler than the graphing calculator. Okay, so we'll do both of these here. So let's go to the next one, which is y is equal to, okay, I'll just zoom out a little bit here. So we'll enter this equation into the y equal. So I'll clear my button there, which is now, for this one here, you have to put it exactly as you see here with 2 open bracket 7, minus 2x, close bracket, open bracket, x plus 10, close bracket. And now you press graph. Notice it's way on the other side. And it seems to be very difficult to see. Now, this is where you need to adjust your window, the graphing calculator. Now, to adjust your window, notice the graph is going way above. I should put this down here. So this graph is going way above your window. This is your window here. So it's above the window, and you barely could see on the left side. So we need to adjust the window. So this is our window here. So if you go back to the graph, this is -10 to +10, +10, and -10. So we'll want to go a little bit beyond -10. So we want maybe x minimum as maybe -20. Okay. Now you'll see there is your y-intercept. You can see your x-intercept here. That's fine, but we don't know if this graph is going up or down. It seems to be going down. Okay. Seems to be going down. So let's look at changing your y coordinates. Go to your window, and I'm going to change my y maximum to maybe 100. See what happens. Yes, so this is the parabola going down. And what will give you an indication is going down, if you look at the x here, if these two were two negatives, then it's a positive. But because it's a -2x times x gives you a -2x squared. So if you were to simplify this for this, we get -2x squared. So it'd be 7 times x is 7x. Then 7 times 10 plus 70. And -2 times -2x times x is -2x squared, because you're multiplying x, 2x, and x. Then you add the exponents, 1 and 1, 2. Then we have -2x times 10 gives you -20x. Simplify this further, what do we end up with? We end up with -2x squared. Now -20 plus 7x. Now -20x plus 7x gives us -13x plus 70. So the y-intercept, when it's written in this form, you can see it should be 70 up here. So that's what the equation, actually, if you simplify, is a quadratic or a parabola. Direction is opening downwards, right? So we can put here, down. The end behavior now is from quadrant 3 to quadrant 4. Okay, so it says quadrant 3 to quadrant 4. Remember, let's do a sketch here of it. So quadrant 3 to quadrant 4. Remember, this is 1 and this is quadrant 2. Okay, so now the sign of a leading coefficient is negative. If it's going down, you can tell it's negative. We'll put here. The y-intercept. Now I can tell here it's 70, but you couldn't have from the original form of the parabola, you couldn't tell. But let's find it from our calculator. Remember your To find the y-intercept, you second trace, go down to and press enter. Let x be 0, y is 70. So there we go. The y-intercept is 70, or 0 is 70. Now, we know there are x-intercepts. We'll find those in a moment, but let's find the vertex. The vertex now would be your maximum value. So you press second trace, go to your maximum. Since you're left bound, so you have to move your cursor to the left of the vertex. Press enter, then move it to the right. Press enter 2 more times, and your vertex is negative 3.25, 91.125. Okay, so that's your vertex. Let's put that down. So negative 3.25, and y is 91.125. So we can 91.3. So your minimum value, there is none because the graph is going down. The maximum value is your y-intercept. Sorry, your y value of the vertex. So this is your y, so it's 91.13. The domain now would be all the real numbers. We say x. The range now, the way you write your range is from negative infinity to the vertex, the y value of the vertex. In this case, it's 91.13. So that will be negative infinity. It's always oops. It's always from negative y going up to 91.13. Now, technically, it doesn't touch here, but we're approximating it. Now, the x-intercepts, what we need to find? We need to find these two x-intercepts. There are two. To find your x-intercept, okay, and and we've done it before, but we'll just determine you go back to your instructions from when you're using it to find the intercept for the linear regression. So it's the same process, and I'll show you how to do it in Desmos also. So we have our equation. First equation is given. Now the next step, enter y in y2, y equals 0. So we go there. We graph that. And here's your y equals 0, which is a line through the x-axis. Then second trace, I'm going to find intersect. Now, I want to find the left one first. I'm going to move down to the left side, further to the below the x-axis. The x-intercept. Press enter, and you do that 3 times, and that's your first intercept, negative 10. So the first one is negative 10. And the second one will be on the right, the other side here. So I'll repeat the process in second trace, find your intersect, then move it over. Enter. And there's your next one. X is 3.5, y is 0. So and 3.5. So there are your intercepts. the maximum value. So we've completed all of the characteristics. Now let's go to Desmos. I'll zoom in here. And let's look at Desmos here. We're going to go to our equation here. Okay. So I'm going to clear this equation here. I don't want it. I'll enter exactly as shown. So we have y equals open bracket 7 minus 2x close bracket open bracket x plus 10. Close bracket. Make sure I have everything correctly. Y is equal to open bracket 7 minus 2x, close bracket, open bracket, x plus 10. Now I hit my cursor down. And as happened with a graphing calculator, it's very difficult to see. So you pinched it, and then there is your graph. Very narrow, but you can actually pinch down so you can see more of it. So you can adjust it. If you're using the computer, then you'll have to use your mouse to zoom in or zoom out. So now we know this graph is going down from quadrant 3 to quadrant 4. Sign of a leading coefficient is negative, right? If it's going down. The y-intercept, let's find that. And the y-intercept is very straightforward in Desmos. You tap where the y-intercept is at 70. Then the vertex, tap on it. The vertex is negative 3.25, 91.125. We round it up to 2 decimal places. Your x-intercepts are all there. So it's much quicker with Desmos, straightforward. There's not much moving around with the cursor. Okay, so that's your number 2. We'll do one more, and then you'll have your chance to try the assignment question. So here we have one, and this one might be a little bit challenging because it seems to be a graph that you'll have some challenges finding. Let's look at what I mean by that. Okay, let's go to my equation. So clear mice. Now I'll keep my y 2 equals 0 because I'll need to find my x-intercepts. So I need that. So I'll put negative. Now remember, as a reminder, and because sometimes you forget, that whenever you're entering the leading coefficient being negative, which we know here right now, so we can put negative here. So we have a leading coefficient as being negative. Okay, let's move it here. So indicate it's the negative in the bracket here. So negative 34.2 x squared plus 8.25 x minus 44. Okay, press graph. Now you see nothing. Now, if I go back to my window here and I press zoom and I go to standard, notice I see nothing. Okay, and you said, hey, where's my graph? The graph is there. Okay. I'll show you Desmos, just a comparison. Now, I'm going to get rid of this graph here. I'm going to do the exact. Compare them. So we have y equals negative 34.2 x, and that's your square button, plus 8.25 x minus 44. Notice where this graph is. It's way down the y-axis. An indication of it is that this graph is going down, and this is your y-intercept. Okay, you can tell from that. So this graph, this is your x-coordinate. You can tell from the graph there's no x-intercept. There's a y-intercept. The graph is going downwards. So now your graphing calculator now, it's very difficult to tell. Okay, well, there's a feature on the graphing calculator that you could use. It's your zoom button and 0. And if you press the zoom button first, and then 0, it will do its stuff. Then you will see the graph. So zoom first and 0. And you'll discover your graph. Now, if you go to your window, you'll see a different range. Your minimum here is negative 3,000, y minimum. But I want to make my minimum here, and keep it here. I want to make my maximum a little bit higher. I'm going to make my maximum, y maximum, maybe 50. And now you can see your x-axis. Now, notice it's too much below the x-axis, so I'm going to change my window. Right now I have 3,000. I don't need to go that far. I can make that negative, there we go here. Change that to negative maybe 100. And there you can see your graph now. So it's a little bit trickier with the graphing calculator because you may not see your graph, but it exists. With Desmos, it's a little bit more straightforward. You can see it's easier on the Desmos. So you have to play around with the graphing calculator. So if you do not see your graph, and assuming you've entered your equation correctly, you press graph, see nothing, press zoom button, and 0. And wait for a few seconds, calculate the work, and you'll see the graph. And from here, you can adjust your window. You probably want to see your x-axis. You go to your window here, and you can see the range. Let's go all the way to negative 3,546.5. So it's way down your x-axis. So you want to adjust it and make that maybe negative, as I said, I use negative 100. You can use different numbers. And I want to bump the y-axis and maybe put negative, oh, sorry about that. That's 100. 100 here. So you have a nice looking scale, and you can tell the x and the y-intercept. So let's go ahead and answer the questions here. The first one, the direction is opening downwards. So we need to pair up. The end behavior is from quadrant 3 to quadrant 4. Notice there's a pattern, right? If it's going down, it's always from quadrant 3 to quadrant 4. If it's going up, it's always from quadrant 2 to quadrant 1. Okay. Now, there's no minimum value. And it's very similar to the other one, right? The domain would be x, all the real numbers. The range will be different. And these, your maximum value, we need to find from your vertex and the y-intercept. Let's go ahead and use Desmos first. And then, so to find our x-intercept, you said there's none. Oops. And then there's no x-intercept. There you go. There are two none in this one here. Now we're going to go on to define your y-intercept. Now I'm going to pinch it to zoom in my y-intercept tab. -44. So it crosses the y-axis at 0, -44. The vertex tab, it's 0.12. Okay, so there's 0. We can round that up to 0.1 or leave the 2 decimal places. And the y coordinate is -43.5. So the maximum value here is your y coordinate for your vertex. So it'd be -43.5. Your range now is from -infinity to the maximum point, which is your y coordinate of your vertex. So we say from -infinity to -43.5. With your graphing calculator, let's find so there's no x-intercept. So we'll find our y-intercept second trace. X equals 0, y equal to -44. This is what we have here. Let's move over here so we can see. Then to find the vertex second trace, find your maximum value in this case. We move to the left, press enter, move to the right, press enter again, and one more time, and that gives me, here it is, -1.2 and -43.5. So today's lesson, our goal was to use the graphing calculator or Desmos to determine the characteristics of the quadratic function. So we determine by inter-interval calculator or Desmos. And if the graph is going up, we know the leading coefficient is positive. If the graph is going down, the leading coefficient is negative. In behavior, we describe the quadrants. It's from quadrant 3 to 4 if it's going down, and from 2 to 1 if it's going up. Find the x-intercept, the minimum value, domain, and range. For your assignment questions, you want to start working on assignment 1. You should have completed this question. And you have question 2, question 3, and question 4. There are also 2 more questions on the next page. Actually, no, there are a few more here on the next page. You can try these for practice questions. I'll take some of these up next session. So that's today's lesson and your assignment. The next lesson I will be reviewing a few of these questions. And after that, we're going to go on to applications of quadratic function. So there are a fair amount of these going on here, and so you'll need your graphing calculator for this. Also, by now, you should be able to complete your hand-in assignment 2.